Okay, so in this 1D kinematics graph review question, we're looking at drawing or choosing an x versus t curve, position versus time curve, when given information from an AT curve, acceleration time curve, and also knowing the initial velocity at time 0. So in this question the object has a constant positive acceleration for a certain time interval, and then has a constant negative acceleration for another time interval. Time intervals look approximately the same, and the negative acceleration looks slightly more negative, but it's pretty close. So there may be some small negative delta v over the entire time interval, since the area under the negative portion might be slightly larger than the area under where it has a positive acceleration. And then we have to sort of choose which of these three graphs or another, if these three are not satisfactory, which of these would best represent the xt position time curve for the car. So what I would start here, in a sense, I would first draw an vt curve from the AT curve, and then draw the xt to see if that's consistent with that vt. So I'll go to a blank page to draw that. So on the blank page. So I've started here indicating that the acceleration, assume that the positive acceleration lasts for a time interval t1, and then the second one lasts between t1 and t2. So I've drawn a vt curve over here indicating times t1 and t2, which are equally spaced on the time axis, and then we're knowing that it has a positive positive velocity at time 0. So I'm indicating the initial velocity having some sort of positive value, vi. And then its initial, I just draw a grid line here, sort of like grid line for ti, and then I can see that there has to be a constant positive increase in the velocity, since that is indicated here by the constant positive acceleration. And as I mentioned, if you really detail and think that this negative acceleration is slightly larger than the positive, we would have to have maybe a slight decrease in the velocity overall. So maybe I'll bring it back to it's almost at rest. But this is the shape of the VT curve. Again, you could choose a higher initial positive velocity, but the initial velocity must be positive, and that the slopes of these lines are very similar. One's going to be positive, one's going to be negative, but they almost have the same magnitude. And you can see that this answer is a distractor, or choice A represents a distractor, as in a sense an incorrect answer. That this is the correct sort of shape, at least, or roughly the right shape for the VT, but not the right shape for the XT. So then to draw a XT curve that's consistent with this VT curve, so XT, and I'll try to split this up roughly evenly, T1 and T2. So knowing that the object is in this case always has a positive velocity, the object will always move in the positive position, so this should span over a large change in x. So I'll start with an initial negative x position, so I can use the whole graph here. You could also have moved the time axis down, that's completely fine. So this is its xi, and we know in a sense that it has a constant increase in velocity, and so this should be a sort of upwards curving parabolic shape, and then it has, then at this sort of inflection point, it will move to sort of a decrease in velocity, so it should be a downward sloping parabolic shape. So again, I'll just draw a small grid line here. And again, this shape, there's nothing quantitative about this particular question. So as long as your graph, I'm going to draw a different color here, is sort of begins with a positive velocity, so there must be some small upward sloping Vt here. It has a positive slope, and sort of moves up to, you can choose, again, we don't know exactly, there's no quantitative values, but as long as it's an upward sloping here, parabolic shape, and then moves to sort of a downward sloping Vt, and it's almost at rest at the end at T2. So that's some small positive slope. Again, you can move the shape of the xt up and down the x-axis, since we're not given any information about the initial x position, but this will definitely be the x versus t shape. You can just arbitrarily choose where the object begins, since we're only told that it has an initial positive velocity, but we're not told what's its initial position. But this one again will be correct, which makes choice B the most correct answer, or best represents here the motion of the car.